Okay, so the second part of our lab is related to EEPROM. So, what's the difference between a ROM and a RAM? RAM is a volatile memory, and ROM is a non-volatile memory. By volatile, we mean that when powered is switched off of a RAM, all the data stored in RAM will be erased or lost. And when power is switched off for a ROM, all the data stored in ROM will remain there whenever we power it on. So RAM can only be coded using special programmers or special set of instructions, but ROM can only be programmed by special programmer or special set of instruction set. But RAM can be read modified using simple syntax that we have done in our lab. So uh, what we can store in RAM will not be erased. So most of the time, ROM in what we store in ROM cannot be erased once we switch it off, power it off or not. So the data stored in ROM is most of the data that we do not want to lose on switching off the power. Like we can say that passwords are the data that we need to store in ROM. So for storing password, we won't be using RAM. We will be using ROM, so it remains there either the power is switched off or not. So to edit the ROM of our microcontroller, we will be using ROM EEPROM editor, and that can be used by simple tools. And there we have EEPROM ROM editor. So first we need to set the input format. It can be string, hex, float, or any. So I have set to string. So over here it defines the address. The address over here is 000 and 0 bit, and it's 01, 02, 03 is till 0f. After that, the addresses become 0010, 00101, 1, and so on. 0011, and address over here will be 0012. Address over here will be 0013 till f, and it will keep on increasing. So most of the time address used over here is actually the address used over here is in hex. So I'm going to just write some data over here in our ROM, and as soon as I enter my this data, it will be written on these addresses. The first six addresses you can see over here, it's written GCOM, and what value shown over here is the ASCII of that characters. So save, save to my project, and use this EEPROM definition in the project. Then close it. So when we look for the instruction set to read and write data in our EEPROM using code, we need to look into the EEPROM library. So there are only two functions. One is EEPROM read and other is EEPROM write. So what EEPROM read does is you give it a certain address in unsigned int in hex form, and it will be return you a byte that what is written on that specific address. And what EEPROM write does is you define a certain address and define a data for it. It will write that specific data to that address. So uh, we'll be using this code I have written. It is advised that do not read or write EEPROM in while one, because every ROM has a certain number of cycles it can be written or read. So when we say that we use in while one, so it will be just in a blink of second it will be used all the cycles. All the cycles will be used. So it is not advised to use uh, EEPROM read or write in while run. So what I have done is I have declared a variable and declare ansel C as 0, ansel D as 0, press D as 0, lati as, and C as 0 because I want to use serial port, and ansel D and will be as a heartbeat LED for my code. So initialize UART at 9600, delay to stabilize my module. Then I will be writing that EEPROM. So in this line of the code, what I will be doing is I will be reading from 0 and storing into this variable and then writing into the next serial port. So I will be doing this till I uh, 05 address, and after that there will be a while one just to ensure that my code is running, still running after even the returns. So once you compile it, you need to compile it using this method. You need to click on this icon, check these boxes, and then press save and save it at desktop or any place you want to do. Once you do so, upload it just as a simple hex file. And once you upload it, so as soon as you write your code and you connect your prolific to your your terminal, so as soon as you press the reset, it will write EEPROM GCRUM, what we have written in our EEPROM, and this was the text we written in UART. So thank you.